Hello, welcome to week 6 of SOL Review. Today we're going to be working on trigonometry. There's a lot of things you have to do, and by that I mean two things really, before you do anything involving trigonometry, the right triangle, sine, cosine, tangent. And the first thing you absolutely want to do is write that key word that we all need to remember. That's sol, ka, toa. And you should write that down on the top of any piece of scratch paper that you have. But you do have another alternative if you are really bad at remembering sol, ka, toa. You will be given a formula sheet on the SOL. And this right here, it's actually on your note sheet right now, tells you sol, ka, toa. It just doesn't use opposite, hypotenuse, adjacent, and hypotenuse. But here's a picture of a right triangle. This is the angle you'll be using. Y is your opposite, X is your adjacent, and Z is your hypotenuse. So you could go back and look at this and relabel it with the O, the A, and the H and replace all the X, Y's, and Z's. So you can write sol, ka, toa, you can use the formula sheet, you can do both. But either way, you need to know this. The other thing you absolutely must do, you cannot get a question right unless you put your calculator in degree mode. Let me show you what that will look like. So here's your calculator. Clear all the rest of this out. If you click mode right here next to second, you can see mine is already in degree mode because it's got the black background and the white letters. That means it has been selected. If you are on radian mode, you will not be able to do very well. You will get every problem wrong. Two things you can do. I'm going to start on the left side of your page. When you are looking for a side is missing or a side has a variable to it. As long as you've got a right triangle with an angle and one labeled side, you can find it. So the first thing you always want to do, and this is true for either one, is pick an angle. Let's change that. Choose an angle. And I would say write it down. When I'm showing you this step-by-step process, this helps you build the equation that you need in order to solve this. In this triangle, you never ever, any triangle, you never ever pick the right angle. You always have to pick one of the acute angles. And given this setup, I would pick the 43-degree angle. I usually draw a little stick figure to denote, hey, this is the angle I've chosen. So I'm going to be setting up my equation over here. I write down the angle of 43. Then you label the sides as opposite, adjacent, and hypotenuse. If you choose to use your formula sheet method, you can label them X, Y, and Z as well. Just remember, not all your triangles are going to be facing in this direction. So, opposite, adjacent, and hypotenuse. Hypotenuse is always across from your right angle. So here's our hypotenuse. Opposite is the same kind of pattern, but opposite the angle you have chosen. That's where our X will be. And down here will be the adjacent side. It's next to the angle we have chosen. Next, you choose the sides to use. You always pick two. And if you're looking for a side, like we are here, you're always going to look for one that's a variable, and you always have to pick one, in this case the hypotenuse, that has a number to it. Whenever you set up one of these equations, you can only have one variable at a time. In this case, we're fine because we're just looking for a side. So because we have chosen this side, our x, and this side, our 25, that means we need to use O and H. And I already skipped step 1 that I told you to do. You need to write sol, ka, toa, just to remind yourself of what you're looking for. Since we are using the opposite and the hypotenuse, the O and the H, only one of these three, the one with sine, uses opposite and hypotenuse. So from here, because we've chosen O and H, we will write the sine of our angle is equal to opposite over hypotenuse. Before I go and solve for this, once you get to this point, there's two things that can happen. Let's say you've got the cosine of some angle equals x over, doesn't matter, some number. Or, let's pick a different one. These are the two possible examples. You're only going to do one of these things at a time. This one is what happens when your variable is on top. This is what happens when your variable is on the bottom. Those are the only two places they're ever going to show up when you're looking for a side. If your variable is ever on top, you take the number that is below it and multiply it to your trig function. So your end equation that you'll be plugging into your calculator will look like this: 20 times the cosine of 15. Here, the variable is on the bottom. So what you're going to do is you're going to multiply the variable to the other side and then divide by this trig function. That's actually just a number in disguise. Don't let the sine, the cosine, and the tangent fool you. But what you're really doing, in short, is switching your variable with your trig function. So you will get, oh, and this is equal to your x, excuse me. Over here, you will get x is equal to 15 over your trig function, the tangent of 20. And I would plug it into the calculator just like that. So looking at these two examples of what's supposed to happen, variable on top, the number moves. Variable on the bottom, the trig function switches with your variable. So here we have the variable on top. That's like one of these examples right here. So all we have to do is take the number below x, move it to the other side by multiplying it. 25 times the sine of 43 will give us our side length of x. At this point, you go to your calculator and just type it in. Clear out of your modes, now that we know we're in degree mode. And type it in, 25 times the sine of 43. Close your parenthesis, hit enter. You're usually going to get a decimal. I like to round it to 2 decimal places because that's usually enough. So 17.049, that 9 will round up the 4. So our answer is x is about, this squiggly equals means approximately. It usually means you've rounded. 17.05. And that's how you find a side. Again, 2 different ways that this problem can end, but the setup is going to be the same as we use for finding an angle, like so. You always start by choosing an angle. In this example, it's going to be whatever you're solving for. Here it is, and I'm still going to write down the angle as x. Step 2, same thing, label sides as opposite, adjacent, and hypotenuse. Since we are here, the hypotenuse is here, the adjacent is here, the opposite is here. And since I had to turn my page, I'm going to write SOHCAHTOA again. Then, pick your sides. Choose 2 sides. In this example, since we've already picked our angle, that's our variable, you have to have 2 numbered known sides. In this case, we'll go with 9 and 13. This will tell us whether we're using sine or cosine or tangent. We have chosen the adjacent and the opposite sides. That's a terrible box. Let me try that again. Much better. So, because we have chosen opposite and adjacent, only one of those 3 will work. Take a second, see if you can set up this equation. Hopefully you started by writing the tangent of our x, yes, we will be solving for that, is equal to opposite over adjacent 13 over 9. At this point, you could plug the 13 over 9 into your calculator to get a decimal, but we don't want to do that because that starts rounding way too early. We want to round at the very, very end of the problem. So the last thing that we notice is our x, what we're trying to solve for, is stuck inside of our trig function, in this case a tangent. So what we are going to do is get it out of there. And what you learned is if you have the variable stuck in here and you want to switch it with your ratio, your fraction over here, that changes this from tangent. It's no longer tangent. This makes us the tangent inverse of our fraction equals our angle. You could put x, you could put the measure of angle x, but the last step is switch variable and the fraction, and then change your trig function, sine or cosine or tangent, to the inverse. And again, that's just the one with the little -1. Once you're here, you're all solved for x. You just have to plug it into your calculator. Remember, we have the inverse tangent, so you will be hitting second, and then whichever one of these buttons, see how in blue right above it has the sine to the -1, cosine to the -1, tangent to the -1, that's your inverse button. Double check and make sure it's there, then plug in, plug in your fraction, 13 over 9. About 55.30. 4 is not big enough to round up the 0, so 55.30 is about what x equals, and that's about the measure of that degree. So x is approximately 55.30. Don't forget about angle of elevation and depression. There's a couple ways this problem could be shown, but the reason I always draw stick figures in my angles, I didn't even draw one here, is because it helps me get perspective on what's across from me, what's opposite, what's next to me, what's adjacent, and hypotenuse is always across from your right angle. But it's really for these problems. If I'm drawing and I have to create my own picture, angle of elevation, you always start from eye level or from wherever you are. If it's on the ground, you start from the ground. And the angle of elevation is to go up from there. Angle of depression, you're usually going to do a problem, let's say you're like up on a cliff or something, and there's something out on the water that you can see. So you'll be hanging out up here. Your angle of depression, looking over at whatever we're looking for, that's what you're looking at. But you started at eye level right there. So the angle of elevation is actually here. Excuse me, I've been saying elevation. We're talking depression now. You're looking down at something. This is the angle of depression. But most of you, and I'm not saying that I'm any different, would try and set up the triangle like this. Nothing wrong with that. Nothing wrong with trying to use the cliff you're standing on as one of the legs of the triangle. But the angle of depression is not in the triangle when we do that. We have to think way back to parallel lines, because if you draw something straight out over something else that's straight out, those lines will be parallel. This line will be our transversal. So the trick that I like to use is if you set this up, your angle of depression is actually right here as well, because these are alternate interior angles of these parallel lines. Your angle of depression will actually be down here by the thing you are looking at if you set your triangle up like this. Let's try a few problems. This covers everything. I'm going to give you a minute, maybe a minute and a half. See if you can figure out what's missing and where to start. I'll give you a hint. Try starting at the top. Alright, I'll start going over this. Hopefully you've gotten at least the x. X is probably the easiest thing you could find here. First thing you always want to notice is we've got a triangle. Two angles are given. X is the third angle. Since we have 180 degrees in a triangle, you take away the other two. 90 plus 30 is 120. That leaves you with 60 degrees, and that's exactly what the measurement of x is. Let's just find L. We have 60. I'm going to write it in. Every time I find something, I'm going to add it to the picture. If we're looking for L, you could use either of these angles. I'm going to stick with 30. Doesn't matter. If you did it with 60, you probably will get to the same answer as me. Because I've done 30, I'm going to be right here. And since I'm about to start doing trigonometry to find a side, I'm going to write so, ka, toa on my page. We have 12. We are looking for L. 30 degrees is my angle. From this angle, this is adjacent and opposite and hypotenuse. I will be using adjacent and hypotenuse for this, which means I'm using the cosine. So I will say that the cosine of 30 is equal to adjacent, I'm going to call that L. If you like x, you can switch to x, doesn't matter, over 12. Take the 12, multiply, because the variable's on top, you get 12 times the cosine of 30 equal to L. At this point, we got to use our calculator. About 10.39. Next is H. We have to find, not our hypotenuse, the height of this triangle. So let me do that in black. I'm still going to use this 30-degree angle. We still have adjacent, opposite, and hypotenuse. I don't want to use the adjacent side because that's got a decimal that we've rounded. But I am solving for H, and I'm still going to use the same 12 feet. I have the 30-degree angle. I'm using opposite and hypotenuse. Opposite and hypotenuse is sine. So the sine of 30 will be equal to H over 12, opposite over hypotenuse. Same story as over here. Multiply the 12. To the calculator. 12 times the sine of 30 will give you exactly 6. H equals 6. Write it right here. Now, the biggest trick with these problems, once you get to here, is cosine and tangent aren't asking you for you to find that. It's asking for what the ratio if we go from angle x. So I'm going to go back and label my sides. We know down here, let me clear some space. So again, for this problem, we're dealing with x and the next one as well. So here's the angle we are going from. We don't need the 60. We're only finding the ratio of sides. We know L is about 10.39. We know H is about 6. So cosine is equal to adjacent over hypotenuse. From here, this is our adjacent side. This is our hypotenuse. 6 over 12 simplifies to 1/2. 1/2. Tangent is opposite over adjacent. That's our 10.39 over 6. Now this is really kind of gross. It will give you a decimal. And you can try and simplify it by hitting math, enter, enter. And it gives you something even worse, 1039 over 600. That's not what we want. Let's think back, because we know that this is going to be something. If we remember, this is a 30, 60, 90 right triangle. Our short leg is 6. To double that, you get to 12. Do you remember the shortcut for a 30, 60, 90? What do you take this 6 and multiply it by to get this 10.39? If you remember this as 6 times the square root of 3, you're right. Now again, this shortcut is helpful. And in these problems, you're probably going to have something that's like a drag and drop sort of problem. So let me show you how you can take this and end up with the right answer of the square root of 3. You will usually have an answer bank to deal with. You will have the opposite over the adjacent, and these will cancel out, and you'll be left with the square root of 3 over 1, which is the square root of 3. But if you only got the decimals, that's what you used, you rounded that, you'll be looking at your answer bank and saying, there's no 1.73, there's no 10.39 over 6. But what you can do is plug in any other answers that you find. And if you see a square root, you always want to know exactly what you're looking at. So take the square root of 3. Whoops. Notice it's 1.73 as well. Remember, we rounded that 10.39, so this is going to be really close, but not exactly the same thing. So if you ever get to this point and you're like, oh no, I see a square root of 3, but I don't see the fraction that I'm looking for, plug in your fraction, plug in your square root. If you rounded, they should be really, really close to each other. Last problem. You've got someone standing over here watching this rocket take off. They're 1,000 meters away. And at 2 different points, they're looking at it at 2 different angles. Whenever you see one of these double triangle problems, I always go back and redraw the triangles. So you'll notice when it stops the first point right here, it is at point B. So C and D are the bottom. B is here. 1,000 meters is there, and a 34-degree angle is here. At point A, the only thing that changes is this point and the fact that it's a 39-degree angle. I'm going to do this in a different color. So C and D, 39 degrees, and point A. This problem, if you can read right here, is talking all about this rocket, blah, blah, blah. But what it cares about is the distance between point A and point B. We want this piece. There is no single calculation that we know how to do that will give us this piece. But what we do know, if you've got a segment that's broken into pieces, we can find AC, the entire thing. We can find BC right here. If you take the whole thing and subtract away another piece that we know, we will be given the missing piece, this distance right here. So what we are looking for is how to find this variable, x. You could call this one over here x as well, just because we're going to be doing y. So if we have y, we have x. What we're trying to do to get the final answer is y minus x. We'll get there. Let's set this up first. Right here, here's the angle we're using. 34. 34. We have been given, one moment, a side right here and a side right here. We have the opposite side. We have the adjacent side. Because we have opposite and adjacent, we have to use the tangent. So coming back to our equation, the tangent of 34 degrees is opposite over adjacent. Our variables on the top, we multiply by that number. 1,000 times the tangent of 34 is equal to x. Hit your calculator. You get 674.51. And we're halfway done. Let's find y. If we have our angle right here, we're going to write that as 39. We'll come back and fill in the rest later. Looking across from our guy, we have y, which is the opposite. we have 1,000, which is still adjacent. So again, opposite and adjacent. We're going to be using the tangent again. So the tangent of 39 degrees is equal to opposite over adjacent. Multiply by the 1,000. Plug it in your calculator. Approximately 809.78. 4 is not big enough to round up the 8, so 0.78 is exactly what we're left with. 80978. So we found our y, found our x. This is the last thing we have to do. Do y minus x. 809.78 minus 674.51 gives us 135.27. And if you're in my classes at this point, if you left your answer like this, I would be screaming at you, 135 what? Because we're dealing with a real world problem, it's not just some number, it's a number of meters. 135.27 meters. Oh, excuse me, we're rounding to the nearest tenth. So instead of 0.27, your final answer, 135.3 meters. I've shown you two very difficult examples, two easy examples. You have a bunch of examples on the next pages. Give them a shot, follow these steps, and trigonometry will never fail you again. Good luck.